Daily Dopamine with Dr. Joe McCullough, where we deliver daily doses of education, entertainment, and inspiration. So sit back, relax, and get ready to be dopamine, dopamine, dopamine. Oh, yeah.
All right, hello, welcome to today's scope. Today is going to be kind of fast, but I'm going to show you something really cool. I'm going to show you, hey Lily, I'm going to steer a beam of electrons using magnets. Hey there. Sergio, welcome. And then I'm going to show you how you can trap electrons in space using magnets. So let me turn this and let me show you what I have here. Hello everybody. Oops, turning off the volume by mistake. Can you guys still hear me? Pleasure to hear you. Somebody give me a heart if I'm still live. Okay, thank you. So what we have here is called an EM apparatus. And I'm going to turn the lights off so you can see it better. But what you're basically seeing is a beam of electrons. And what I'm going to do is show you how you can steer the beam and then how you can trap electrons in space real fast. So I've got these two power supplies, high voltage and a low voltage, connected to this EM device. What I'm going to do is set this down, and then I'm going to turn off the lights so you have a better view and explain a little bit about what's going on. So I'll be back. Thought we could never accurately know where electrons were, electron cloud, etc. Great question, Sergio, but I'll touch on that in a future scope, but we can know where electrons are. We can follow this beam right here. Let me turn this off. Okay, let me close this other door, and then we'll see. Hopefully you'll still be able to see. Okay, so what you're seeing here is a beam of electrons. And by changing the magnetic field, so under here, I have these coils of wire. And by sending current through the coils, I create a magnetic field, and moving charged particles are deflected by a magnetic field. So I can steer the electrons. Whoops, let's do this other one. So right now, these electrons are just coming out of this filament. And when I change the amount of current going through the coils, I can get the electrons to start to move in a circular path. And now what I'm going to show you is something called a magnetic bottle. You can actually trap electrons in space using strong magnetic field. So first I'm going to bring a magnet nearby. Whoa, what happened there? Let's see if I get this back. I'm going to bring a magnet nearby, and you can see I'm starting to steer the electrons. So the electrons are getting affected by the magnetic field of this bar magnet. And this is actually just a Cal magnet. And so what I'm going to do is get two magnets on either side, and if I can arrange the magnets just right, you'll see the electrons trapped in space. It'll look kind of blurry, so it's not going to be ideal, but the blur you're seeing are electrons bouncing back and forth between the poles of the magnets. So let me get this up high. I'm going to have to move so you can see it from an angle. And this is not, had trouble setting this up. So let's see if I can get this to work. So, why is that happening? Let me tweak this a bit. Okay, there we go. So now I'm going to take the magnets. You'll see that when I get the magnet nearby, I can actually bend the electrons. Now, one thing to say is you're not actually seeing the electrons themselves. Electrons are way too small to see with the naked eye. What you're seeing is the path of the electrons. There's a gas inside this glass canister, and when the electrons hit the gas, they excite them to an excited state, and when the gas de-excites, it emits light. And the color of the light that you're seeing has to do with the gas that's inside this glass tube. So now let me see if I can trap the electrons. So I'm bringing one magnet nearby in the front, getting the other magnet in the back, and if I can get it just right, now you can kind of see these electrons aren't actually touching the glass globe. They are bouncing back and forth in between the two magnets, creating what's called a magnetic bottle. And this is basically what's happening to the charged particles moving back and forth between the Earth's magnetic fields. So again, one more time, what you're seeing is the path that the electrons took. Charged particles are deflected by a magnetic field if they're moving. And what I'm doing is using this magnet to actually deflect the electrons. And then if I use two magnets on either side, I can get this so the electrons are bouncing back and forth, there we go, between the two strong magnetic poles of these magnets. This is called a magnetic bottle. You're basically trapping electrons in space. Thanks for being part of our homeschool day. Why, awesome. Okay, so I know that was super fast. Tuesdays, woo, bright, bright, bright. Tuesdays are like my 9-hour teaching day, and it's just about time to go home. But we had that set up for another lab, so I just wanted to show it to you. If you're tuning in tomorrow, Wednesdays, our weekly Ask a Physicist Anything. Tomorrow we're going to talk about the twin paradox, which is a lot of people know from relativity, has to do with what happens if one twin stays on Earth, the other twin leaves on a spaceship traveling near the speed of light. So we're going to talk about that. Okay, well, that's it. My name is Joe. Thank you so much for joining. I hope you have a wonderful Tuesday, and I hope to see you tomorrow.